Right. Um. Yeah, we're gonna let me switch this. Yep. Okay. So um, we are continuing from where we left off yesterday. Um, we are. Let me just turn down this volume. Actually, I think we're looking at the Rust book and chapter 12. That's building a command line program, it's called mini-grep. We did it yesterday, and we continue today. Yeah, I mean, let's see if we can wrap up this chapter. I mean, the goal is really just to um get very familiar with the language. So yeah, chapter 12. I think I think we did a lot of things on refactoring. We'll see that. Yeah, maybe we can get to chapter 13 today, but let's see how far we can go. Yeah. Meanwhile, uh, yeah, I had this. Yeah. So, I got like a keyboard, like split keyboard. This is the left split here. Um, well, I also have another kind of keyboard. This is the wireless one. The other one I showed is the wired keyboard. Yeah, I was using the wired one for a bit, but for some weird reason, the right split wasn't working. I tried to flash it and troubleshoot. Yeah, so yeah, I only used it since what? Okay, I used it yesterday and today during the day. But anyway, I'll take care of that later. So I'm back to my wireless keyboard to this one actually. Yeah, I'm back to it. I was already getting very comfortable with the wired one, like how it feels and everything. But anyway, that's something that was bothering me before now. It made me start the stream a bit late because I was trying to fix it. Yeah, and then this headphones is also low in battery, so I'm connecting it. But anyway, let's get going now that that's off the way. So let's try to see where we left things off from yesterday. Um, so this is the um mini-grep. I mean, it's called mini-grep because what we're doing is a command line program, but it's really just going to be doing grepping. Yeah. Uh, just to show what we've done, we we have. I mean, we didn't start it as we didn't start this program like modular. It was really just a binary crate. We just had things directly in the main function, and then we started to split things up. So we started with the main function, and we in the end we had to create our own result type, which yep, is our own result type, which has like a which has a uh, result, which is a result of like a generic type and our own error, as you see. So this is our own error, in which can have two variants: insufficient arguments and problem reading file. And as you see, we also implement from error for our error type. Yeah, and yeah, that's for IO error. Yeah, so we can basically go from an IO error to a mini-grep error, as we do in the here, right? Is it here? Yep, here. Actually, is it here? Yes, here. So mini-grep run returns a result, and then content. Interestingly, why does this work? Because content is a result that contains a string. So why is it not? Oh wait, oh maybe it depends on what is here actually. Yeah, this returns a mini-grep error, and this one. Hmm. I was expecting. Oh yeah, I think this is going to return. It's going to print a result, so it's okay. But why don't we simply have this thing as like so? Why not? Yep, exactly. This is how it should be, to be honest. Yeah, because we're printing just a string. Okay. Now, having looked at that one, let's see what. Oh yeah, we also saw. What? So this is the new. This is the associated function, or like you can say constructor, that constructs a config for us. Basically, we give it the arguments. We give it arguments from the environment, which is an array, basically, and then we try to extract a config from it. As you can see, the config is a struct, has query and file path, and we try to get those from the arguments that comes from the environment. Yeah, okay, or we give it a error. Same thing with file path, same. Yeah, and then we return a result from here. That's a mini-grep result. Yeah. Um, exactly. So I think having seen that, we can move on. So this is how they handled errors here. They just used array length, but for us, we took care of it properly. Maybe they did that subsequently, but let's see. Calling config build. Wait, what's config build actually? Oh yeah, they called it build. And look, they are returning a result, and they are using static lifetime for this. Isn't this interesting? Because what they have done, so it returns config or oh okay, or like string literal or like a string slice, sorry, but with a static lifetime because it doesn't change. So um that's what they return from here. But for us, we are actually returning yep a mini-grep result, which is even better. Interestingly, uh, Okay. Anyway, that's something else I wanted to look at. But yeah, so that's what they did. And then so they call this build. That's okay. Handling errors. So they're doing this in the main function, and this is so in case you're not able to build, because build is returning a result, yeah, and then they're printing okay, and then they're doing process exit. Right, what did we even do? Ours is slightly different. We did, I mean, all right, for us we are returning a mini-grep result, which is um result and mini-grep error, yeah, which is our own type. I mean, these things are sort of equivalent. This returns unit type as is, which is basically what we are doing. Yeah. So unwrap or else, and then problem parsing arguments, and you have the error. So the actual error that that will be returned from build is what gets printed here. In our case, what did we do? Yeah, we are returning the error, and that error is going to be returned all the way to um, yeah, it's going to be, I mean, the executor is going to just exit. So we didn't have to handle this process exit ourselves, because like here's what I mean. um, so I'm running, doing cargo run and passing the arguments to it. So basically this thing needs um, two arguments. One is the text search for, second one is the file. Yeah, and we have the file poem.txt, but as you see, poem is like poem.txp we're doing here, so it's wrong file name. And if we execute this, wait, yep, yeah, so we have our error. That's it, and it exits. So this is exactly what will happen here as well. But actually, I'm now curious. Anyway, I don't want to change this. It's, so if I get the, for them, config build gives you results. Ah, right. Okay. Okay. So they're printing the error directly. Mini-grep run. So anyway, run is also coming from the library. So we remember we move things into a library. This is in lib.rs, and we expose a public function that takes the config and then uses the internals of the library to read the file and give us a result that has like result. This is mini-grep result is our own type, right? In this case. Yep. So that's it. Okay. We haven't covered it. Unwrap or else. Yeah, Unwrap or else allows us to define some custom non-panic error handling. If the result is an OK value, this method's behavior is similar to Unwrap. It returns the inner value. However, if there is an error, this method calls the code in the closure, which is an anonymous function. I think this is actually pretty important. We define and pass an argument on wrap or else. For now, you just need to know that on wrap or else will pass the inner value of the error. Okay. Well, for us, our error is an actual is mini-grep error. So we define our error here, which is fine. One thing I want to see is I probably want to have a different version to see this. But then how do we run this? Because mini-grep run is also going to return us okay. I think now I so that's this config. Okay, another thing we can do is inside here then we'll do mini-grep run. But this can also give us an error. Anyway, at least we know how unwrap or else functions. What else did I want to do? So extracting logic from main. So going back to the program's logic, we want to extract a function named run that will hold all the current logic in main. Well, we already did that in our case. Yeah, we even for them they like they made run a function inside of main RS. For us, run is in our library. Okay. Returning errors from run. Yeah, which they did by making run return result or like box of error. Okay. I mean, one thing that we did is that we just yeah, I mean, we were able to make main itself return our type. Like we didn't have to do box there, which also works fine. Okay, so for the error type, we use the trait object boxed in error. For now, just note that box in error means the function will return a type that implements error trait. Well, of course, yeah. But mini-grep error. Yeah. mini-grep error doesn't implement error actually. It's just error here. But anyway, we know. So we didn't need we didn't use the boxed in error like generic error. We just defined our own error types. A type, yeah, and that's the only thing we want to return from here, like our own error, yeah. So I mean, the code is just similar. Aha. So this is what they did here. So there is an if let rather than unwrap or else. Splitting code into a library crate. Anyway, so I want to change something here. So wait 1 second. Yep. Okay, I think I want to get rid of this wire here. Yep. Yep. So one of the things that they did here is, I mean, I want to change this to, this is a result. Yeah, it's a result that gives us config or mini-grep error. So first, let's say that this doesn't this doesn't return a mini-grep error. Instead, it doesn't return. I mean, it's just regular main. Doesn't do anything. Then I want that. So I want to get the config, or based on what is returned from the config, I do something. I mean, I print the error. So let's get config, and then based so if or let's rather get config or error, and then if error, we should print error and exit. Yeah, so I want to do. So now this is result. So let's use the unwrap or else that we're talking about. Wait, oh yeah, okay. Like I said, I'm using a I switched my keyboards now. So yeah. I don't think I've configured, the two keyboards are not configured the same, but whatever. So now the error, which is a mini-grep error. So basically unwrap, let's give us the content of the result, what's in the okay value of the result. Otherwise, run disclosure. Yeah. So get the error and do something with it. Now print line. So there's the print macro, and say unable to I'm unable to get config. Yeah, and then I just say error would be error. So, but anyway, error is a, we probably might need to, but anyway, let's see. Yeah, unwrap or else. So give it just the config, or it does that. Do we have a problem? Yeah, so it says mini-grep error doesn't implement display trait. So yeah, we can't print it as I imagined. It's mini-grep error is the enum, but we can yeah, we can use a debug. So mismatch types expected, config found unit type. I guess that is because of this, maybe. Okay, and then so now we have config. We can no, wait, no, that is not exactly what we want to do, because even if you print this that you're unable to we want to what will happen to the program? It will still go on to the next line, right? Yep, even though you have an error. So that's just returning an error. It doesn't exit. So we need to do two things. So we need to we need to wait, okay, we need to do this, and we need to process, right? So std, wait, sorry, process, yes, std process. Exit. What's the code we need to use? So to terminate the current process. This function will never return and will immediately terminate the current process. Exit code is passed through the underlying OS and will be available for consumption. Note that this function never returns. No destructors and cost that. What are the codes, by the way? Okay. So if a clean shutdown is needed, it is recommended to only call this function at a known point where there are no more destructors left, or preferably simply run the type implementing termination, such as exit code or result from the function, and avoid this altogether. Wait, I think it's probably in the I'm looking for the termination. is like from a command. I think it's called termination. Wait, I think it's termination. Exit code. Exit code. Is it called termination status or what is it? Process termination. That's what I just saw. So every time there's implementing termination trait has to be covered. So what are the implementers of this? Structs exit status. Is a struct. So exit code is intended for terminating the currently running process via the termination trait, in contrast to exit status, which represents the termination of a child process. So exit code is what we should use. So if we say exit code, so this is doing I'm doing process that exit and the code, the exit code. Yep. Like so. This matched. So what is a constant actually? No, I think. So what is that supposed to be? Exit. I mean, exit status default value is 1, which indicates a successful completion. Yes, so code status dot code. What did they do actually here? It said 1. This thing is this is what we're looking at just now. So maybe I should read it slowly. So the type represents the status code of the current process and can return to its parent on a normal termination. The code is intended to be consumed by the standard library via a termination report. Standard library provides success, failure codes, as well as going from 8 to exit code. So possibility. Numeric values in this type don't have portable meanings. Different platforms may mask different amounts of them. The platforms can declare successful and unsuccessful codes, see success and failure as items. Success, which is an exit code. Know that this returning main implicitly results in a successful termination. There is no need to return this from main unless you also return that because okay. And failure. Yeah, but how does it map to 1 and to like they're even doing exit code from? So again, exit code is a struct and it can be built and has a value, and do you have examples here? They do. So exit code can return from the main. It implements termination. Exit code from, and you're returning a particular exit code. Otherwise, exit code success. But so what are the yep, okay, that's what I was looking for actually. So basically success is like 0 and then failure is going to return 1. But as if you say exit code, that explains why they're doing process exit 1. Right, okay. So if you're going to do from, and then you give it the value, you say you can't do failure, wait, yeah, anyway, so you can just say 1 or yeah, and that's it. Let's not get distracted, let's go on. So anyway, we have our config. If we are not able to get the config, we exit after printing the error. When we finally get that, we can we want to run this, yeah, and I think, yeah, I saw them do it differently. They did a run which returns a result as well, I needed a I think it was something like if let um I think this was returning us a result as a string, right? Yeah, returns us mini-grep result, can be a string. So I think it so basically if mini-grep run can destructure into an OK of like content. Yeah. I think yep. Then you want to do this, yeah. Then you want to print the result. You want to print the content. Otherwise, you know that there was a failure. So, see, I did an if let here, and by the way, this can actually yeah, it can. We want to read the this can give us we have a problem reading from here, but that's like on the file system level. We already checked the path is correct here, but we can still have problems. Maybe it's corrupted or something. So this can also give us an error here. Yeah. So what happens if we but anyway we already print the content. So at this point we can as well also exit, right? Um yeah. And we can also exit here. Well, even though I prefer what we had before, but I wanted to just like check, I mean, see how this other one will look. Um, it doesn't print, right? No, it doesn't. Um, so it just runs, and there's a problem. The problem actually reading the configuration. So, but it does not print us this. Interesting. Yeah, but that's it, right? Yeah. This was the previous one. Or am I not seeing this? Yeah, it doesn't do that. So what's wrong? So the config unwrap or oh wait. It doesn't get the okay. Yeah. It actually gets two things. So this is fine. That's why it doesn't give any issues. But yep. Exactly. So it exits. That's what I was saying. We might have a problem no wait, hold on. Why does this not fail? When we try to get the config, what do we do there, by the way? Yeah, we only check that it's provided. We don't check that the file path is valid. We don't check that. So that's why actually, where should that even be? Should that be when we want to run it? We might as well. Where do we have problem opening file? Do we wait? Problem reading file. Oh, that's when we try to go from the IO error to, but do we, this is meant to be used, right? Interesting. I guess we removed with the usage when we change our code. Ah, yes. Yeah, we removed it because when we were returning mini-grep result from here, that is, and using the question mark operator to automatically go from error to, from mini-grep error to error, that was handled automatically for us because we have the from trait implementation. But now that it's no longer there, yeah, we don't get this out of the box. So we have to handle this. And that was being handled here. So like, so at this point we run it, or maybe I would put it config build. Probably it's better to put it here, and this should maybe like not be new, should be build. So yeah, that's fine, but I think I'll do it here. So after checking the both of them, that the file path that the file path was provided, let's check that file path exists. Yeah, so what do we have in, what do we have in the file system? Exists. So exists, it will return true if the path points to an existing entity. Yeah. So we can use this. So we can say it returns a bool. Okay, it returns a result that is like a bool, an error. And here we're returning mini-grep result. So anyway, exists. So we want to, if it doesn't exist, we want to like get an error or like return a mini-grep error. But so maybe what we should do is let's say, so we want to go, actually we don't need the file, it's just the error that we care about. Yeah, so Can we do a map error? Which is an error. Yeah, the error for file system exists should be an IO error, right? IO results. I think it's an IO error, and we already have that for mini-grep error. So I think we are able to automatically go from that. Let's see what we do in build again. In build, it's saying unwrap, or yeah, we print the error. I think all we just need to do is to return that. Exactly. So we just need to return. We don't need to map error actually. So exists. But we are not doing anything with that actually. Expected value. Path, yeah, of course. I think it's file path, yeah. Actually, this is, yep, let's see. Yeah, this is going to return no, I think what I need is something so if file exists can be destructured into if file exists can be destructured into error, some error actually. Yeah. Then I want to I want to return a mini-grep result, or actually a mini-grep error. I thought this would happen automatically. Well, whatever. Like, why actually am I not able to do? I guess I can do mini-grep error from. Can I do that? Yeah. Yeah. So I have an error here. I can actually do a return. Here. Wait, what? Why does it not work? Oh wait. So this is like checking if file exists. Of course it doesn't work. Wait. Yeah. So should we check? We should be doing wait. If we say if file exists, returns an error. But yeah, that's how it's supposed to be. Then this is the error. Yeah, if file exists, gives error. Wait, let's see. It says poem.txp exists. What did we do wrong here actually? So this is, it came to the else block. So basically checking file exists on that. Oh yeah. Why does this, what is this? Wait. So let's look at the definition again. So it returns okay. True, a bool. Right. If the path points to an existing entity as opposed to path exists method, this will only return okay, true, okay, false. Ah, yeah, we're doing, I think we should be using path exists. Oh, yeah. Look, we didn't even look at the definition. That's a problem. File exists returns okay. It's bool. I mean, I thought this was like a separate type. No, it's actually IO result and bool. So it's okay, true, or okay, false. And the path was verified to exist or not exist. It will generally give you an okay, true or false. If its existence can either be confirmed or denied, an error will be propagated instead. It's going to be a case of listing permissions. So this is not what we need to use. I think we should look at what path exist does actually. Is it like path? like path exists currently on no, it's like path struct, yeah, exists. That also gives you true, just true. Um, just gives you true. Okay. Path. All right. So I think it's so we're simply doing actually let's keep it as file exists, and we know this is going to give us okay of bool. I think I prefer the path exists because it's easier to not miss that, right? So um yeah, so it's gonna be um if path path exists um yeah, I think we would then have to do like path new. Yep. Right. Maybe all of this is not even, yeah. So if this um doesn't exist, I think then we do this. I think yeah, they have a path new, create a path and then just do exists on it. Also, we don't even need to do that. So we can just do, you can just call exist on it. Same thing. Yeah, that's the same thing on it. So if the file does not exist, if the path does not exist, I'm going to return a mini-grep error. Yeah, the error, right? Okay. We can't do it like this, so we have to say we have to create an error. Actually, maybe it's easier for us to just say. So I think this got a little more got a lot more complicated. I would have preferred what we had before. I think it's like actually prefer what we had before, to be honest. And then course. Yeah, okay, now it does what it's supposed to do. Yeah, so now we get unable to get config. We get unable to get config. The error is problem reading file. File does not exist. Yeah, so this was being printed here for us, and our code exits. Yeah, I don't like this. But anyway, it does what it should do. I mean, I wanted to see how if I say txt the correct thing, then it prints. Yeah, I mean, I like what we had before. It was a very straightforward, neat, organized, and straight to the point. This is like get away, get off. I don't want this. I'm reverting it. Here. So first, I want to revert the change. To be honest, I don't like what's that? I think it's like grep. Mini-grep result. Do I even wait? Yeah. Okay. So what next? So we have the config. I don't want to do any unwrap or anything. Go away. Give me the config as is. Oh yeah. Why did this become new? It's supposed to be build, right? That's what we had before. Oh, that's was yeah. And then the run. This returns a let me have content. Nope. Yeah. Like, isn't this much neater and like straightforward? Like it is. So the wrong thing gives you the error directly, like, yeah, problem reading file, no such file exists. And if I do the right thing, voila. You know what, like, it's what we have is like much better and not even bothering. Okay, that's it. So moving on. Spend too much time on this part, to be honest. Yeah, they have their code. We see how it is, but nope, I don't want to. So now splitting code into a library crate. So I want to split main.rs and put some code in library. We already did that, to be honest. So, but I think you're doing something else here. So I want to define, the search responsibility, which is something we haven't done. Let's define the code responsible for searching the text in the library rather than that. I think so far we don't have any search functionality. So anyone will use the mini-grep because we put it in the library. Okay. So we don't define a search function. Oh, what was unimplemented? Actually, with the body that's called unimplemented macro. So I didn't know about this unimplemented macro. Okay. So, again, this is the entry point to our library. We have a run. Why? I mean, I will go to grep here. Oh yes, in the library is where I need to have a public function so it can be used. Yeah, I thought I was already meant it. But inside of the grep, search search text in file whatever query string slice. What was the signature here again? Content. Yeah, so we would basically give the content. So it's actually not in file. Search. I just say text in whatever. Just say text. So query and then the content, which is also reference to something. What does it give you? A vector, like that has the matches, right? Or like has the so basically what? Yeah, anyway, vector of string slices, which is okay. Vector of string slices. Now, because the inputs are both references and the output is also reference, you have to introduce lifetimes here. I'm going to give all of them the same lifetime. Oh yeah, and we say, how was it called? Unimplemented. I actually didn't know about this one before. Oh, probably don't need this, yeah. Okay, unimplemented indicates unimplemented code by panicking with the message of not implemented. So that allows your code to type check. Okay. So there's also a to-do macro. So while to-do conveys the intent of implementing the functionality later, the message is not yet implemented. Unimplemented makes no such claims. This message is not implemented. Okay. Fine. What? Oh wait. Use of undeclared lifetime name. yeah, we have to declare the lifetime before we can use it. Okay. Now, so we've used the public keyword, the function definition to designate as part of our libraries. Library creates public API. We now have a library crate that we can use from our binary crate that we can test. Yep, okay. And now we need to bring the code defined in the library into scope. So this was done in the library. Well, for me, that was not in the library. I also have like a... Okay, well, let's see. Yeah, we need to bring the code defined in the library into the scope of the binary crate. Which is what they did here. And then they're saying, after reading it and getting content in run, okay, so run is in, so they have run in main, which gets the content and does the search in main. What did we do? For us, we get so I mean, so they have a main and then they have main calling run here. So for us, and then main was passing the config. Yeah, passing the config to run. So basically, after getting the config like this, they just pass the config to run. For us, yeah, we have the config and we are calling run from our library. Does that even make sense? Actually, no. Every client of the library would run it differently. So the library shouldn't specify run. Library should only specify should only wait, by the way, hold on. Okay. So wait, let's see. I need to check what they did. How did they get so did they config the build, and config build is happening in main is what they did, which makes sense. What's about wait? Does your library even need the config? It doesn't. So this is like in terms of organization right now, like organizing code. Yeah. So let's take a look at our library. In the library, we have we have the grep here, and grep module, and we have config here. Why is config here? Why is config here? Because so our library is meant to read a file and do search, right? So that's it. Like, or rather search something in a file. But why does it need to know about uh, the config? At the end of the day, you pass it the file name and the text to search for. Library shouldn't be bothered with um, building the configuration, because actually it doesn't even know how to do that. Well, I should not know how to do that, because that's what I'm seeing that they did here. Okay. Yeah, they kept these things in main and, which I think makes sense. And run is just taking contents, printing it, and here where, yeah, so now you only have the search here. So again, you're going to have read content and you're going to have search there. That's it. That's it. Uh, 1 second. I mean, do we have anything here actually? I think I'll start tracking changes I'm making into this. No comments yet. It's okay. So I want to start tracking changes here. Oh man. Okay. Right. So I just want to make sure I don't lose changes. I don't want to have to go back to doing things there. I'm just creating a repository and for this. Yeah. Okay. But let's just push this. I mean, like, not push, sorry. Let's commit. Let's track our changes. We need to first add the files, right? So can we add everything there? Can we? Yeah. What's left? Okay. Yeah, I think that's basically everything. what do we do? Yeah, okay, so the read file works, whatever. Yep, read works. So we can now, I want to move things, I want to change things a bit. I don't want I think the config can stay, yeah, the config like this can stay in main. Yeah, so I have a config and it does this. Cannot find type mini-grep. But yeah, anyway, it's okay. So fail to resolve that. Excuse me. So mini-grep, grep and errors. I think we need to import two of them. I think I need to take some tea. So we need to import grep and error. Wait, why can't we do this? Yeah, grep. Oh yeah, true. We can't do it like so because it's not. It's coming from no grep. But I think grep is there, but we also have like mini-grep, grep, and errors. Yep. So yeah. What else am I missing? So yeah, here we can have a config, which yeah should leave with this and then in main we basically build the config, yeah, and run should be like how this should work should not be in the library, right? So yeah, just a wrapper now. Yep. So maybe what we need to do in our librs like this is not run, but actually read content of a file, and it should be read content, and it should not take the config, but it should take a file path. What with nothing there actually. Wait. The config is actually a file path, yeah. and it should be like this. Um, cannot find. Yeah, exactly. And read contents, what we said, yeah. So mm-hmm. um so I mean, this is just the wrapper on the other one, because we wanted to separate things and have like grep as a sub module, right? It's a it's like a sub module of our library, or like a module of our library. Our library is here in, so everything that should be exposed from the library is in it's in lib.rs, and here now we what it says fails to grab. Yeah, okay. This is no longer coming from here. It's right here. Config is here. Config build the config, and there's no longer run, but um getting the content from the library, or rather, yeah, the library knows how to read, to do. Wait. Well, yeah. Let's say the library exposes. Um, hmm, what did these guys do? Yeah, the library doesn't need to read it. Yep, which makes sense. We should read the content ourselves. Yeah, because this should be, we are the user of the library, so all of this code, the library should basically be doing something that's reusable. The library shouldn't be reading the content. Yeah, because this, what's this? This is yeah. So let's say here now it's so I think they call it run. And this would take the config, yeah. And yeah, try to get the contents based on the config. Basically what we have there actually. And this is what we need. Std file system for yeah, read to string, and it needs the path, which is config dot file path. Okay, this is the result of string or error, and so give me string, and then I take that and I will now call search on it. Right. Call library search on it. But yeah, problem is run has to return mini-grep result string or yeah. Okay, then or actually it doesn't need to be that. It should just be like this. And then we have this. We should say run config. Yeah, that's pretty much it. It's okay. And if I go here, as here now, yep, read content, this is no longer, yeah, library should not do that anymore. Should just do a search as unimplemented. Main does takes care of extracting the, so because like it's the one that knows, the color of the program is the one that knows how the how that the configuration should be built based on its own environment. The library is just going to say, give me what I need to do my job. Yeah, and that's it. That's why main is reading the environment variables, building its own configuration, and calling its own run function that does the execution of things. Cool. So now, yeah, this is the kind of thing that, yeah, I think we are very close now. So now we are going through the lines of, for lines in search. Oh, basically we're searching every line. What is oh, rather, because like a search in the library takes the query that needs to be searched for, looked for, and the content as a reference to the content that we read, and then it will give us back a vector of like, I guess of vector of string slices, and we're printing it. So let's see. So we add a use mini-grep search line to bring that into scope. In the run function, rather than printing out the content of the file, we call the search function to pass the query and the content. Then run will use a for loop to print each line returned from search. Okay. Okay, so you should note that the function will be collecting all the results into a vector. It returns before any printing happens. It could be slow to display results when searching large files because results aren't printed as they are found. Possibly, we discuss possible ways to use iterators to fix this later on. Okay. But yeah, okay. So search remained unimplemented in this. Yeah, okay. I think so. Yeah, search. So this is what we're going to be doing. I'm saying query that's like config.query, and the content here would be what? Yeah, content. Actually, content. Yeah, but in any case, I mean, it's not implemented, so we will have an unimplemented what is your problem? Cannot find function read content in grep. Where's that? Okay, we still have something that is there. Yeah, we don't have read content anymore. Actually, we should have grep. We should have a search. We should, because there's no way to reach grep unless we go through, like, well, we have to have the entry point and deliver the RS, so we basically need a public function search. Yeah, that takes like a query and the content that we want to look in. Yeah, and then gives us back the vector. I mean, it's basically the same signature as what we have there. I wonder if there's a different way to do this, but because yeah, because we have inputs, like two input parameters that are references, and also like a vector that like has a reference. We need to define a lifetime. We can basically give them same lifetime. Yeah. Same thing here as well. Yeah. Okay. I think this is what we want to do. Oh, come on. Why no references? This expression creates a reference which is immediately dereferenced. What do you mean? Okay. Create a reference which is immediately dereferenced by the compiler. Interesting. Configure query and content. Oh wait. Wait. I think that's not my interest right now. Let's yeah, okay. It's linked. So I think it says that's a needless borrow. I see that, but let's first. Yep, that's what we want to see. Not implemented, and we're good right now. Okay, so let's see. I think that's the end of this section. So I'm gonna move to the next one. So adding functionality with test-driven development. So we're still building on this mini-grep thing. Okay. So we have the search logic separate from the main function. And now it's going to be much easier for us to write tests for the core functionality. Yeah, we can call functions directly with various arguments and check return values without having to call our binary. Yep. Okay. So now we want to add searching logic to the mini-grep program using the test-driven development. So I'm going to write a test that fails and run it to make sure it fails for the reason that we expect. We'll modify just enough, make it pass, and then we refactor the code. Just added or change to make sure the tests continue to pass. Okay, that's cool. I mean that's so basically what we're gonna do is we have an unimplemented method that we write test against. Classic. Yeah, and then until it passes. Yeah. So this is one of the many ways to write software, TDD. So the Rust guys advocating test-driven development can help drive code design. So we write the test before we write the code. Let's make the test pass. Can help maintain high coverage throughout the process. Okay, so we're going to test drive the implementation of the functionality. I'll actually do searching for the query string in the file content and produce a list of lines that match the query. So let's write a failing test. So what do we want the test to do? So we should add it. So in the library, we should add a test module. So basically what you're talking about is a unit test. The test function specifies the behavior we want the search function to have. To a query and the text to search. And it will only return the lines from the text that contain the query. So let's try to write this maybe by ourselves and then see. Yeah. Okay, so this is the URL, so the library basically, and sorry, wait, let me see something. Okay. Anyway, so we need to add we need to write tests for the library, so that yeah, what was that thing he said there? He said so we can call functions directly with various arguments and check and return values without having to call a binary. Yeah, so we're writing tests against the core functionality of our code. Yep. So let's try to write a test for this that we fail until we add the correct implementation. So this is a unit test because unit tests are usually within the same file, and we add the section of the code that will instruct the that will prevent building the whole test, adding test to the binary. So let's add the attribute in the configuration attribute. Test. Yeah. And we add a test module, and we can now have our test methods. Yeah. So should do what? Yeah. Should find match given query. And yeah, so we can do actually we first need to bring everything here into scope, right? Super, we can bring in grep, we can bring in all, so it's in scope. Like everything here is just in scope. That's the standard way to do it. Now we can say search and query should be like pizza, and the content yeah and the content that we want to search for, wait, hold on, let me, maybe it should be like this. So let query be yeah, so let query be pizza, and let content be I once had pizza at a restaurant. Where's my, sorry, on this keyboard, like, yep. It was tasty and delicious. That's it. Okay. That's the content. And this would be query content, and it's going to give me back a vector, right? So let result be that, yeah. And now we want to assert that assert equals result dot length, yeah, length is 1. Yeah, so this is the first thing I want to assert. I mean, should find match. So I just want to assert length first. Well, this is not going to run because it doesn't have a test attribute on it. So now it does. And now it's going to run. Yeah. So this should be a failing test. Cargo test. Yay, it failed. Yeah. So one failed, and it failed because did you say why it failed? It failed because like panic that not implemented. Yeah. So there's a panic there. That's why it fails. Okay, that's cool. Let's see what they did actually. So they have a query and they have content. Okay. Backslash what? Okay. And this and docs is there as well, and it won't be found. So there are certain what is returned from it, that it's like what, safe, fast, productive. Okay, this test searches for the string docked, and it will definitely fail. All right, definitely fail. I mean the one we have actually beta 1, yeah. Okay, text we're searching for is 3 lines. Text we're searching is 3 lines. Okay, only one contains docked. Actually, no. Oh yeah, docked here. Okay, only one contains docked. Notice the backslash after the opening double quote. Tells Rust not to put a new line character at the beginning of the content of the string literal. Oh yeah. Okay. So it tells Rust not to put a new line character at the beginning of the contents of the string literal. So what I did for mine was like this, and then I did new line afterwards. So basically we can do this, in fact, and then do this. Wait. No. Yeah. This. Yeah. Okay. So I think result. I think maybe it's probably better to say yeah, vector of like strings. You'd be like, I once had pizza at a restaurant is the only thing that should be returned. Maybe I say what, where, when. Okay. Well, at least I know that this is what should pass. This is pizza. Yeah, this is the only thing. This is the only line that has pizza. So if I do this and I say yeah, result should be that, then we know that yeah, okay, it's fine. Yeah, and then we set the value return search, but if we run this test, it actually failed because of an implemented macro. We panic to the message not implemented. In accordance with utility principles, we take a step of adding just enough code, yeah, to get the test to not panic. So, okay, I like the approach. I like the approach generally, yeah. So, which is instead of uh, this, yeah, then you return just an empty vector. Nice. And then you do cargo test. Yep, it fails. It fails because so left is I once had a pizza at the restaurant. Right is an empty array. Cool. So we want to discuss why we need an explicit lifetime in the signature of the search. And use a lifetime with the content argument and the return value. So if you recall that the lifetime parameters specify which argument is connected to the lifetime of the return value, correct? In this case, we indicate that the return vector should contain string slices that reference slices of the argument content rather than query. Or we indicating that the return vector, yeah, should contain string slices that reference slices of the argument. Yep, that's true. Yeah, so yeah, I had even missed that. I didn't. We don't need to make that. As far as we specify this, then it's okay. It just needs to be of. Yeah. Is it here now? Yeah. It doesn't need to be for both of them. Yeah. Okay. Makes sense. So, in other words, we tell Ross that the data returned by its search function will live as long as the data passed into the search function in the const argument is important. The data referenced by the slice needs to be valid for the reference to be valid. The compiler assume we're making uh, string size of query rather than content. It will do its safety check incorrectly. Okay. If we forget the lifetime annotations and try to compile it, then we get that. Yeah, we know about that already. Ross cannot know which of the two parameters we need for the output. So instead, explicitly, the help test suggests specifying the same lifetime parameter for all parameters and output type. Okay, that's what we did, and it's saying it's incorrect. Yeah, because content is the parameter that contains all of our text we want to return, the part of the text that match. Okay, correct. We know content is the only parameter that should be connected to the return value in the lifetime syntax. Yeah. Okay. Well, but what happens if you give all of them the same? It if you give all of them the same, I mean, I don't I don't see the problem with that. It just means that um it just means that they have the same lifetime, and uh the the content of the vector will live as long as the content you read and also the query lives. So it's there's no problem there, but this is just more accurate. That's all. I mean, this expresses the intent. Yeah. Other programming languages don't require you to connect arguments to return values in the signature, but this practice gets easier over time. To be honest, like I wish Rust didn't have this. It's just very it's unnecessarily complicated. I mean, this part. I mean, lifetime, the whole lifetime thing. I mean, I get why. It's just it should be taken care of. Like there's already lifetime elision rules, but just not enough. Yeah. Anyway, hopefully it's. I mean, let's move on. So other programming languages don't require you to connect arguments to return values. Is signature, yeah, but this practical, yeah, okay. You might want to compare this example with example in chapter 10. I think I saw yeah, I mean we've done that. We've done that before. It's okay. So writing code to pass the test. I think I'm probably getting a little cold. Just 1 second. I need to keep a little warm. All right. let's continue. This is currently, yeah, okay. So once write the code to pass the test, yeah. So it's failing right now because we're returning an empty vector. Now we have to implement our search, and our program needs to follow these steps. I like how they're doing it, like laying out the steps so we can even implement it and then check afterwards. So if you iterate through each line of the content, check whether the line contains our query string. If it does, add it to the list of values we're returning. If it doesn't, do nothing, and then return the list of results that match. Okay, so let us implement that. So we want to iterate through content. So content is string, so we need to iterate through each line of content. So content would definitely contain lines. So we need to how do we get we need to split it at a character, right? Like we need to be able to, or at the new line character, yeah. So like multiple lines, how do we get like let's do this. So we have lines. So this is first an iterator. So over the lines of a string as string slices, the struct created with lines, method on str. Yeah, so lines. So we can do lines, yeah, and we have an iterator. This is gonna give us an iterator, yeah, and we can try to find we can then try to find, oh wait, no, not lines actually, should be, I'm just gonna call it item, right, in lines. Now we need to see if this matches, like if that particular item is a match with query, right? So so basically if item dot contains, yeah, it's going to return true or false. Contains query. Yeah. Okay. So when it contains query, if it does contain query, then yeah, we want to, if it does contain query, so wait, first our vector, we need to first create the vector that we want to return. So let result be a vector of like so let's result be a vector what it said mismatch type expected struct expected well anyway is it because no wait found unit type what does that mean for loops found unit type found loops so evaluate unit type what do you mean for item in content.lines then iterator anyway let's move on first so if item contains query then we want to say result dot push want to push value to the vector and push item there wait yeah look at why it's supposed to be an if yeah so if that yeah and then we will return result but the result is not initialized come on yeah oh yeah it has to be mutable yep okay so now let's try to run our test so yeah it does pass now actually so our test does pass okay yeah where are we okay yeah I think that's what they did here as well yeah so at this point we could consider opportunities for refactoring the implementation of search function while keeping test passing to maintain same functionality. The code is not too bad, but it doesn't take advantage of some useful features of iterators. Yeah. So let's explore those things. So we're going to return to this example in chapter 13. We'll explore iterators in detail and look at how to improve it. Cool. Now let's try a word that will match multiple lines like body. Well, let's go multiple lines. Where is the example again? Where's the poem even? I think it was like, oh yeah, body will match like 1, 2, multiple lines. Yeah. So this is for cargo run, not the test. That's fine. I can do that too. So cargo run body poem text. Oh yeah. Um. Okay, it doesn't print, right? Like we didn't print. I think we changed. Uh, implementation. Yeah, so it just searches. I think there was says reference is referenced. Yeah, because it doesn't do it. So we mhm. All right, now let's result. Yeah, be that. Then we want to print result. Yeah, it doesn't implement that. Okay. Yeah. So it found the body in like these 3 lines. Okay, that's fine. And monomorphization. Once chef check search for something that is not there. What did I do actually? It says it was no such file or directory. What? What? Oh yeah. No, that's not correct because it's like and then poem. Oh, poem. I think what I did was poem. No, it's like poem. It should be yeah, yeah. So result is empty. Okay, so that's correct. So excellent. We built our own mini version of the classic tool, and learn how to structure up applications. A little bit about input output lifetimes testing, command line parsing. So briefly demonstrate how to work with environment variables, how to print standard error, both of which are useful. So let's go to the next thing. So we made some changes. I just say yeah. So basic search. Okay, let's now. So now I'm going to work with environment variables. So I want to improve the mini-grep binary by adding an extra feature. Yeah, that's one of the things I I was checking for earlier, but I want to move on with this. So anyway, an option for case insensitive searching that the user can turn on via an environment variable. Could make this feature a commanded option and require that users enter it each time they want to apply. But by instead making an environment variable, we allow users to set the environment variable once and have all their searches be case insensitive interval session. Okay. So we're gonna writing a failing test for case insensitive search. Let's do that for our test. Wait. Yeah. Okay. Oh, whatever. Let's do that here. So we need to add a test case. The attribute should given I mean, I don't want to think too much about this. What should it do? It should find, yeah, should find match given different case sensitivity. I mean, that's long. Sorry, that's long. Just means upper, lower case, whatever. Okay. So, just like what we have here, right? And we want this test to fail. I'm actually just gonna copy it and paste it here. We have query like pizza, and here I'm gonna say like pizza like so, and I want to assert that it should so this test is going to fail right now. I want it to fail, and then it should only pass after the fix, because like it should not wait, hold on, like right now it will return empty, so type annotations needed, cannot infer type. So that the result is empty, you cannot infer that. Wait, no, I think, can't I just do this? You can compare unknown and as an array, right, with like a vector partial compare. How do I compare. Do I have an assert? Is there valid inhabited not equal? I mean, I'm just going to say length. Say the past. Why? You have pizza, and you once had So actually, no, that's not what I want to do. I want to say that it actually gives me. Okay, that's what I should have done here. Yeah. Was it not like the query is with lowercase, and this has like uppercase, yeah. Oh wait. Yep. This has uppercase. What should we get? Yeah. You shouldn't find it. We're using contains. You shouldn't find it at all. And in this case, we are trying to assert that it's found, so it should fail. Yeah. So unless like I don't know what contains does, we can check that. Cargo test. Yeah, it fails. Exactly. So because like left says this, but right returns empty. So this is what should happen. Okay. Or rather, I think they just call it case insensitive. I think I like that. For us, we change. Yeah, it fails now. It should pass after. Yeah. So I think I'm also getting a little bit tired. Maybe that's. Let's go on. So now the case insensitive search uses this in the query. Okay. Note that we've edited the old test content too. We've added a new line with the text. What did we do there? So case sensitive, we did like this. Why? We've added a new line with the text duct tape using the capital. That shouldn't match the query. Okay, so basically it's like we don't want to break the existing thing, right? Changing the old test in this way helps us ensure that we don't accidentally break the case sensitive search functionality that we already had implemented. This should pass now and it should continue to pass. I get what you mean. What I have in my search case sensitive. I have pizza here. It's fine. Yeah, this is the one that fails. I have pizza here and pizza, and it fails. That's fine for me. I don't know what. Yeah. So the new test for the case insensitive search uses like this in its query. In this search case insensitive function we're about to add. Oh, you want to add a separate function. Right. I see. So you are doing search and you're doing search case insensitive. Okay. So this should match the line containing rows. Okay. Yeah, it's a different so now I want to implement case insensitive. Yeah. Anyway, I'm not sure why they decided to make it separate functions, to be honest. Because like, why not make it the same? Anyway, let's just follow what they're doing. Like we can just do that here. I'll pass a flag to this and be done. Okay, so yeah, we should do like to lowercase and also to lowercase. A trade bound. It says the trade bound is not satisfied. Consider borrowing here. Actually, it can be the same thing here. Oh. Wait. Okay. Don't tell me that I lost that. Okay, I'd like a swap file. But anyway, because of the abrupt way it ended or exited. Put expression. That's okay. So we have a case. We have, implementation for two of them, and I think for the test now. Wait, no. Before we even get to test, like we need to have in the library a search that also does case. Hey, Uchikar, how's it going? I hope I pronounced your name right. How's it going? Um, okay, so yeah, the case insensitive search, which currently fails. I think it's gonna be, yeah. Mm-hmm. Okay, so why does it? Oh, it fails because, yeah. Um, this is pizza and this is this. That's why it was failing. And now it passes. Okay. Um, so now we call this search case insensitive from the run function. First, we add a configuration to the lowercase. That's okay. So now that both tests pass, we want to call search case insensitive function from run function. Okay, so you mean instead of using search, okay? First we add a configuration option to the config to switch between either case sensitive or case insensitive. Mm-hmm. Adding this field to cause compiler, we cause compiler errors because we aren't initializing this field yet. Okay. We aren't initializing this field, just this one. Um, let me see that actually. I think its config is in main. What's this complaint about? The expression creates a reference that is immediately dereferenced. Yeah, we take care of that after. Anyway, config. We want to add a. I think it's public. Yeah, public. Ignore case. Bool. And you said it's going to complain. Let's see. The compiler will complain. Cargo build. Yeah, it does actually. Why is that? Oh, yeah, because we don't initialize. Okay, I wanted to see. Yeah, because we are building. I think it's in main. Where are we doing that actually? Here. Yep. There's the complaint. Okay. Yeah, so there has to be like a default that we choose. How did ignore face? So next we need the run function to check the ignore case field and use what we decide. So basically, if you check this, you use either this or that, still won't compile. Okay. Yeah, it won't compile if you are doing it in the run here, because here we are returning that, where we need to build a config and we don't know what should be. Yeah. Yeah, okay. And wait 1 second. Yeah. And yeah, okay, so finally we need to check for the environment variable. So yeah, we add another one for ignore case. Okay, so that one we specified it for the variable. We use var function from environment variable, from the environment module, to check and see if value has been set from an environment variable named ignore case. Okay, and then we do that there. Okay, that's cool. So we can yeah, we need to execute two code paths here. I mean, like one of two code paths here. So kind of simple if, it's if else, because it's boolean. It's bool. So if the what config dot ignore case, then we are doing this. Yeah. Now we're doing this. Else we are doing mini-grep search case sensitive. I don't need this. Yeah, it'll tell me about but that's still on compile, of course, we said that already. So we are getting 1, 2 here. We need to our case is equal to environment. How is that? Wait, var, like so, okay. So fetches the environment variable key from the current process. Returns var error and not present. Variable is not set. So the key, right? And the key here is ignore case. Okay. Yeah, so it returns a string if it's set, otherwise a var error. Yeah. So So if this is set, if it's set, then we know that, wait, no, actually ignore case. What would that, okay. Yeah, because it's a result, so we can just do convert this to bool by doing it's okay. Okay, that's true. And then we can say ignore case. Yep. Okay. So it says if the variable is set to any value, it will return the error variant in the environment variable. If the variable is not set, okay, writing this okay method on the result to check whether the environment variable is set, which means the program should do a case sensitive search. If the ignore case environment variable isn't set to anything, it's okay return false. Yeah, okay. We don't care about the value in the environment variable, just whether it's a set or unset. So we're checking it's okay rather than unwrap or expect any of the methods. Yeah, so ignore case can be whatever. We don't care as long as it's set. So we pass the value. We pass the value in ignore case variable to the config instance, so the run function can read that. So like this now, 2, it's matching this and that without it being set. Should match, see any of the words all in lowercase. Looks like that still works. Now let's run the program with ignore case set to 1. So ignore case and then that. So making it explicit for the, or you can do, if you're using PowerShell, separate commands. That's what PowerShell anyway. This will make ignore case specific for the remainder of your shell session. Can be unset with the remove. That's okay. We should get lines that contain 2 that might have been uppercase. Yeah, like this one. Okay, so let's run it and see. Come on, where are you? Don't tell me my keyboard has stopped. Wait. Okay. I need to restart this keyboard. Like, I'm not sure why these keyboards are doing. It used to be inactivity, but now it's not inactivity. Anyway. Yep. Okay, so we do a cargo run. We can say poem. So yeah, we didn't print this, that's why, right? Because we said, I mean, so you mean that we don't need this? Is that it? and result be of vector type that is so wait no wait okay, and then yeah, we can say like that result is that yep, it needs to be mutable. I always forget to add mutable. And here we say result is that, and then we do a print line and we say result. Well, because result, actually we should do debug. Okay, and let's do what we did again. Yep. So wait a minute, we're running this with our case insensitivity. So I know. Oh well, yeah, correct. If config does ignore case, no, it's not correct. So there's a bool, right? So this should be it here. We should really switch this like so, and this should be like so. So if we run this again, yep, now it gives us it should match only the ones that are case sensitive, and if we I think it was like wait how do you, it's like so. So we say like no case yeah. Okay, so ignore case is set now, and then it's doing that. Okay. What happens if I run this again? Okay, it's gone. So just for okay, one time. So now we got lines containing that in our mini-grep program to do case insensitive searching, controlled by an environment variable. Now we know how to manage options set using either command line arguments or environment variables. Yeah. Okay. Some programs allow arguments and environment variables for the same configuration. In those cases, the programs decide that one or the other takes precedence. For another exercise on your own, try controlling case sensitivity through either a command line argument or an environment variable. Decide whether the command line argument or the environment variable should take precedence. If the program is run with one set to case sensitive and one set to ignore. The std environment module contains many more useful just waiting to remember us. Okay. I think we've had enough practice on this one. We should move on. Redirecting errors to standard error. So modify things a bit. Try to commit if an expression, if it's an expression, so you can wait. Sorry, let me make this easier. I don't know if it is. So you say if it's an expression, so you can make it return the value to initialize the result. If you don't put the empty vector, Kaggle complains. Yeah, exactly. So here, like here. So you're saying it's an expression, we can make it return the value. Oh, yeah, you mean that instead of this, I just return from here. Yeah. Yeah, I think I wanted to print. I want to print, but I didn't want to do this like twice, like inside of the both of them. Yeah. Is that what you mean? Yeah. So just because of the print, no need. Okay, yeah, no need because like of the print you mean, I guess. Yeah, otherwise I'll have to can do something like let VB else is missing. I'm not sure I get the I'm not sure I get what you mean. So we have like the result initialized to empty vector. I think that's what you are referring to. If returns the last expression of each branch. Yes. So what happens with I mean I that's fine for if but what happens with printing, right? So we want to print for both of them. So you're saying let meet result be if okay. Ah, okay. I see. Yeah, because it's an expression, so it will return one of both branches in the end, and you don't have to initialize. That's your point. Yep. But why is this complaining now? Remove the on the. Oh yeah, because it's an expression, and I think the same thing on that one, right? Is it? Yeah, it's an expression, so this is expected here. We also don't need to have like so. Okay, and same here. Yeah, now it doesn't need to be mutable any longer. This is much better. Um, yep. Yeah. Okay. Yeah, it's yeah. Okay, and then the results equals. So basically, this would also, yeah. Mm-hmm. Yeah, I think this is much better. Yeah, I like. Mm-hmm. All right. Did this work or not? Um, what did we do? Um, in our case, for search. Yeah. So now, going on to redirecting errors to standard error. So right now we are writing all of our output to the terminal using print line macro. In most terminals, there are two kinds of output: standard output for general information and standard error for messages. Mm-hmm. So this thing enables users to choose to direct successful output of the program, but still print their messages to screen. Cool. Print line macro is only capable of printing to standard output, so I have to use something else to print standard error. So I want to observe how the content printed by mini-grep is currently being written to standard output, including error messages. We want to write a standard error instead. So we want to do that by redirecting the standard output stream to a file while intentionally causing an error. We want to redirect the standard error stream, so any content sent to the standard error will continue to display on screen. Okay. You can act as crappy clippy. Right? You have to run clippy. Yeah. Okay. Cool. Cool. Yeah. Interestingly, Clippy didn't say anything about that. Like Clippy didn't complain. Did you see? I mean, I would expect Clippy to say, "Hey, you don't have to initialize this. This is." He didn't say anything. He was quiet about it. Is that how you call Clippy crappy? Okay. Yeah. So, command line programs are expected to send errors to the standard error stream so that we can see error messages on the screen. If we redirect the standard output stream to a file, our program is not currently well behaved. We're about to see that it saves the error message output. Wait, we're about to see that it saves the error message output to a file instead. Command line programs are expected to send error messages to the standard error stream, so I can still see our error messages on the screen, even if we redirect that output stream to a file. Okay, our program is not currently well behaved. We're about to see that it saves the error message output to a file instead. Let's see. It thought I wasn't running Clippy. Didn't it catch that? It didn't catch that. It didn't catch that. Normally, Clippy would wait. There's no result for diagnostics. Like normally, Clippy would it would run like when I save like that. It would The cargo clip you saw, it was analyzing just now, right? You said that. See, cargo clip would run. So it's there, but it didn't catch that. Yeah, it didn't. Okay, so to demonstrate the behavior, we run our program with um, folder and the file path to say like send things there, right? I'll put a txt um, that we want to redirect. So that's this. That's we want to redirect the standard output stream to that file. We won't pass any arguments, which should cause an error. Okay, let's do that. Whatever. So cargo run, and then we say output.txt. So now the file doesn't have anything. It's empty. So this syntax tells the shell to write the contents of the standard output to output.txt instead of the screen. Yeah, that's output. Yeah, we didn't see the error message we're expecting. Nope. What did we do wrong now? So wait, I guess wait, maybe I have an idea what's going on. So we should see this, or like at least the errors. We should. I know why. Wait. So the program that they have, like the program they have here, their version of the program does things a bit different from ours. All right. So what we are returning errors. I mean, we are returning a mini-grep error in this case, and in our main function, it's still just a mini-grep error. So it's, but for them, what they were doing was like when there's an error, when there's an error, they actually do a print line. They do a print line, and they actually print the error, and that's what they were talking about. So the print macro is what. Okay, so we will not. How do we change? What do we do to this is what I'm talking about, right? So they were actually doing a print. You wonder if we can initialize a variable using that if while returning the function name, as both functions have the same signature. Let's see what you mean. So I wonder if we can initialize a variable using that if by returning the function name. Savers can do that without having to do something extra. Yes, to then call the selected function. I'm not sure I get what you mean. You want to initialize a variable, which is the result now, using the if, just if, yeah, okay. but returning the function name. As both functions have the same signature. You want to return the function name. So something like function if function one. So if condition in function one, else function two, and then do function and okay. So what will be the type of function? So wait. So you want to return with Rust infer the type. Well, we have to see. So you want to do yeah, search, yeah. Okay, and then this is function one, and then else you want to do function two. But isn't that don't call? Oh, we shouldn't call it, right? So how do you mean we should just like this? Just make a search. Okay. Is that even possible? Let's find out. Okay, well, ignore case. Okay, I think it's like this. Oh, look, function. Okay. So let's see. Why is this one complaining? Oh yeah, wait. First, this has to be like so. Okay. Then, yeah, exactly. And then we can call it in the end because it's like the same, right? So we can then say function result. Interesting. Okay. And I think it does it, yeah. It does. So we just I mean this is what is gonna be result in the end, yeah, so right. Oh no, yeah. Should I even say let's do this. that's it. That's actually it. Okay. So the type is a function that takes like string slice, and returns a vector because they both have the same signatures, and that's why it's doing this. Okay. I mean, I know this was possible to do actually in Rust. Okay. So but like I can't escape the second well, I can't. I just do wait, no. I just do this. What is that one now? Where did the error come in? Yeah. Okay. You could do the call. You could call the function just after the after here. You mean yeah, or the if. Yeah. But if I call the, I guess kind of cryptic. Exactly. That's what that's what I'm looking at. I'm like, yeah, it's actually kind of cryptic. Like it's not. It's so that's why I kept this one just to look compared to them, but it's cool. Yeah, you're right. I mean, it's good to know that this is possible to do. Yeah, function result. I mean, I didn't know you could return functions. Uh, this is really cool. Yeah. I didn't know it would be possible. I don't know if it would be possible. Um, or you're saying you could call the function just after this of the if. So like after this of the if, what about the else? Like you mean, well, how do you mean? Like if blah, if blah blah else that, and then okay, so if this else that P1 P2, so you put that you mean like where do you call the function then? Because the function itself is, oh, you mean not to use the let again, right? Like, oh, what I don't um. So where do you mean like when you say there, you mean for. What does that mean? I mean, I'm trying to read what you mean here, but it's not very clear to me actually. Yeah. But yeah, I mean, I think it's cool that we can do this. Yeah. Um, yeah, I'm just gonna move on to this one, but I think it's cool that uh, this can happen. But yeah, Okay, let me see what this. I was referring to um the errors. So like redirecting the print or the standard output to a file. Yeah, and then I was saying that how they, maybe I should even go there, but in their own version of the program, they were using the print macro to print the errors. Yeah, but in um in this version that I have here, we're not doing that. Like, is it? Yeah, we're not doing that. So in our main method, where is it? Yeah, this main here. We we don't print the error. Like we don't use print line. Yeah, we don't use print line. Yeah. Okay. Yeah. What you got? Like. Yeah. I mean, yeah. I will try that maybe also later. But I wanted to see because I might need to change this code. I mean, not this code, but like I might need to change the implementation here so we can test what they want us to test here. So what I'm trying to say is that uh, you see we run it and then the output is empty, and that's because of how we write the program or how we wrote the program. Print line doesn't print to. I mean, we don't print the error messages. Um, how are they even showing? Like they were just showing. Yeah, exactly. That's why there's nothing on the output because of because we're not doing a print line. So if we're to change that, what we would do is to change um, the main function from returning this to maybe returning unit type, and then or like not return the error there, just print the error. I think I should change that so we can test what we want to test. Basically, when we build this, yeah, when we build this, we can get the errors from here, and we basically um, do a print line on the error. Same thing for the run. If we get an error there, we also print. I think that's what we should do. Yeah. Um, okay. So what did I do now? Yeah. Okay. I wanted to make this a little bit short, like smaller, so I can see. Yeah. Okay. Then I will change this to not return. So it should just return the default unit type and yeah, and this should no longer do this. We have a config. So I'm going to say like if this is a result that gives us config, right? So if wait, I can say wait, no, hold on, no, oh wait, I can say um dot unwrap or else. So like give me what is in the result. Otherwise execute the closure here. And this is an error, so it's a mini-grep error, and do something with it. No, that's not. Yeah, do. I think. Yeah, I think I was correct with that. Yeah. Wait. Yeah, we can do this. So it's an error, and we we want to print the error to. Want to print the error? Yeah. Um, and then so this is about building the config, and then we say unable to build config. Yeah. Unable to build. I mean, I prefer the other version to be honest, but we need to do it how they want because we're following this example here. Unable to build config, and the error is and the error is this. Error wait, yeah, exactly. And otherwise we're gonna get the config. Yeah. So I have the config. Next, we want to run this. Run also returns us a mini-grep result. We can also do, we can say if, if let, yeah, okay. That is going to give us, I think it's like, is it a string? What do we get even? Like, what's the mini-grep result again? Okay, it's generic. But what do we return from run? Oh, actually, right now, run is not giving us anything. Is it possible that we get? Oh wait, yeah, actually, if it's an error, is that not when we care to print the error? Yeah. Otherwise, like, just do what we have to do, I guess. I think it's the error I care about. So if run destructures and gives me an error, yeah. So if run can be destructured to give me an error. Wait. Yeah, then I also want to do a print line. Failed to run, and I say what the error is. Error. And mismatch types. Ah yes, this is wait, why? Okay, let's look at what the issues are. First of all, let config the if expression. Wait. So the syntax error, first one. Expected a block if let. Oh, I think it's this that's the problem. shouldn't be like so, yeah. What is it? Syntax error. What is this? Closure bodies that contain statements but surrounded by braces. Okay, so that was correct. What we had before was correct then, right? The if expression is missing a block after this condition. What block do you need? Oh wait, it's, I don't think we need, it's not supposed to be, yeah, I think it's not supposed to be an if there. Mismatch types, expected config found unit type. Okay. You say you're saying that build returns unit type, is that it? But it doesn't return unit. What does it return? It returns config this. Okay, let's look closely at this. What am I missing? Mismatch types, expected config, found unit type. So you know what, like, wait. What's wrong here? Config build argument, unwrap or else is a closure. So I'm saying like, otherwise like execute the closure. Oh wait, yeah, exactly. It actually returns a unit type, yeah, because this closure, actually, or else the error, right? So I think that's what the problem is. So, and that is supposed to be config, right? Yeah, otherwise the error, so I want to print, so it's mini-grep error. Wait, hold on, let me, wait, what is unwrap or else returns the content OK value or computes its own from the closure. Turns the content OK. Yep. So the value that will be inside of the, yep. What then do we want for the config? Is this what we want actually? Do we want to use unwrap or else? Or is it like something else we want to use. Or is it? There's actually unwrap or error. Wait, no. Or okay, unwrap error. No, I think it's on unwrap or else. But this needs to be a config. In this case, I mean based on the closure. But anyway, so what we want to do if we look at this again, what I want to do is to print the error, basically, and then yep, that's true. I think I remember what we should do here. We should do we should get process, and we should exit at this point. There's no need to do anything. There's nothing we need to do here. We should do process exit 1. That's it. Yep. And so we will have the config or we exit. It's a terminal program, nothing more we should do. And then if we are able to, I mean, if we try to do run, and it destructures to an error, we should also print this. And I think we should also exit, right? Yep. I mean, it should exit normally. So I think this is what needs to happen. Yeah. So now let's run this again. Wait, before we run this, I want to just make sure that let me delete this file, even though I think it's going to overwrite it, but let's see. What? You didn't run? Okay. So I ran this without any. Yep. Okay. So now it's yeah, now we see stuff there in the file. I ran this without any arguments, and said send the output to, or rather, what was that name? They said this means like the syntax tells the shell to write the contents of the standard output to output the txt instead of the screen. We didn't see the error messages we were expecting. Yeah, so there are no longer error messages here, but the error messages went to the file, so it means it must have ended up in the file. Yeah, and that's what we have here. Unable to build config, and the error is insufficient arguments. Please provide a query to be looked up. Yeah. Okay. So yeah, it just took the yeah. So when we specify, so let's sit 1 second. Yeah, so when we specify an output, a file that should stream the output to, we no longer see errors on our screen. So I think that's what they were talking about. Wait, what? changes added. What do you mean? Yeah, okay. No, I don't want to. I don't want to stage. Yeah. Come on. Yep. I didn't print for errors. Okay. Okay, so let's go on. Yep, our errors are being printed to, or our error message has been printed to standard output. Which is more useful for messages like this, be printed to stand. Wait. It's more useful for messages like for error messages like this be printed to standard error. So basically, our error messages are printed to standard output when they should go to standard error. Yeah, so that only data from a successful run ends up in the file. So let's change that. So printed error, standard error. Okay, so because of the refactoring we did previously, you're saying all of the code that prints error is in one function. So I see why they did it like this. So they're like, okay, yeah, interesting. Okay, cool. I get why they did it. And then they also even did they did this something like this as well. They did like if let error, then they also did the exits. We didn't do that, did we? We didn't exit. I would expect it to exit. Whatever, like. Okay, so let's now run the program again. So the change now from print line, standard library provides an print line macro that prints to the standard error stream. Let's change that. Print line. So print the standard error with a new line. I combine to print line macro so that it goes to the standard error instead of standard output. Okay. Okay. Let's run our code again. Yeah. So now that we use the print line, error print line, we have the errors on display. And okay, and the errors don't go to the output. Makes sense. Now we set errors on screen and output txt contains nothing, which is behavior expect of command line programs. Cool. So let's run the program again with arguments that don't cause an error but still redirect standard error. Okay. I'm just going to copy this. So there are no errors. Yeah. Okay, standard output is here. Result. Okay. That's actually because I am printing it like so. Actually, wait. So is the vector? Mm, wait, what's anyway? That's fine. Um, it's okay. At least we know. Um, okay, so this is one now using standard output for successful output and standard error for uh error output is appropriate. Okay, so we got that, and um, we're now prepared to write command line applications combined with concepts from previous chapter. Our code will be well organized. Study it effectively. The appropriate data structures, handle errors nicely and well tested. Okay, we want to explore some of Rust's features that were influenced by functional languages, closures, and iterators. Right. Okay, so I'm thinking this is a new chapter. Nice. So I'll do this in the morning, yeah. Um maybe like yeah, I'll do this in the morning. This chapter. Maybe also like chapter 14 as well. Let's see. All right. Thank you very much for joining the stream. Yeah, I have also something planned to. I have this app I'm building with Rust, yes, but also with Claude. Yeah. So maybe I do that later in the day too. Yeah. All right. Thank you, Utrikar. Yeah. All right, and see you. See you later. Bye.